And I am live. That is pretty nice. Today is 14th of October 2025, Tuesday. And yes, there have been a little change of plans. I thought naively that I will reach 6,000, which is okay. I will reach 2,000, the rating of 2,000, which is okay, right? Which is like completely okay. Hmm? Of course, anyone can reach a rating of 2,000, I think. And I also up am a part of anyone, so I will also be able to reach a rating of 2,000, which is okay. Yes, of course, I will reach 2,000. But on top of that, saying that I will do this very hard thing in 6 months is naivety. That is a little bad. And now I can like see it more clearly that this is bad. Saying that I will reach 2,000 by the end of this year is not a good plan if I actually want to reach 2,000. So I am going to extend the limit by the end of the next year to actually reach 2,000. And yeah, that seems like a good decision. Not delaying the inevitable, but asking for the necessary time to be able to reach 2,000, right? So that I'm not just thinking about reaching 2,000, but taking actual steps. And yes, this is nice. This is nice because this is going to be, or this is one of the hardest things I have done in my life. And putting a time limit on top of it is not a very good idea. So yeah, so I will be going not slow, but at the right pace for reaching 2,000. And what that means, like what the TLDR is just that I will also be doing a couple of shit, a couple of other things while, um, yeah, during in the way I will be doing a couple of different things also. And well, the first thing is competitive programming, of course, which I am doing and I will be doing till I reach 2,000 and after that. But I also wanted to do. I have been like holding back for a few months at this point, and I cannot any longer. And I just want to do different things. So second thing is Rust. I did 2 streams on Rust, and they were very fun. I learned a lot of new things, a lot of like different ways to look at the world. So yeah, I want to do that more. So Rust is the second thing, and there is the third thing, which I forgot. Shit. Yes, there was also one. Yeah, shit. Yes, yes. Building projects. Yeah, projects in C++. Yeah, these are the three things that I will be doing. The three things on which I will be streaming. And today's stream is competitive programming, and I will be alternating between Rust and projects. I think I will start a project stream starting from tomorrow, and we will be building fun, amazing things. First of all, we will build our own Redis in C++ database. Yes, build your own database from scratch here, Redis. This is going to be fun. And when I know Rust good enough, I will also do this and build Redis server client in Rust. This is just amazing. This is just beautiful. This is very appealing, very, very appealing. And since I'm like not stopping myself from doing other things other than competitive programming, eh, just the amount of freedom that there is like pretty crazy because I can also do other things like LFS. If you do not know about LFS, you just need to know this much that if there is a human being who has done LFS, then that human being is closer to some other entities than a normal human. That human being is living at a higher conscious awareness plane that than normal human beings, right? Like you can just think of that human being as if she, whoever it is closer to enlightenment than any other human being if they do LFS. And what is LFS? LFS is this thing, Linux from scratch. What is LFS? Linux from scratch. Shit. In this, person who is doing LFS, they have to get source code of all the things, like literally the Linux kernel and all the dependencies which go with the kernel, and compile them for their own machine and run it. Like they are literally not even using any uh, distribution. They are going to GitHub or kernel.org, this website which has the Linux kernel. They are going here and downloading the source code of Linux, like this thing. And that is crazy. Just building Linux literally from scratch. That is a crazy thing. Yeah, crazy is a very small word to describe someone who is doing LFS. And yes, now this is crazy. Like literally, shit. Look at this. Look at this. Uh, okay, this is not Linux from scratch. This is Linux from scratch, but I thought they might be cloning the literal Git repository. And let me show you Git repository, how much time it takes. Let me go to something. Stuff, Git clone, Git dot, I think to clone the Linux kernel. How do we clone the Linux kernel? Kernel.org, Git, this thing, I guess, https git.kernel.org. So git clone https colon slash slash git.kernel.org. I think that is not how we do. Yeah, that is wrong. That is wrong. Git repository hosted here. Okay, I guess how do we clone this thing locally? Tarball, we can download Tarball if you want to, but browse. Okay, if we want to browse, we can go here. And do we do kernel.org.git to do this? I guess we can clone this from Mr. Torvald's website dot linux.git. Okay, git clone. Nope, not silly. Git clone colon slash slash github.com slash torvalds slash linux.git. This should work. This is working. And just look at how big this thing is. The internet speed is something at max 4 Mbps from just 3 Mbps, and this thing is massive. This thing is massive. We have downloaded 60 MBs and we are still just 1% there. So this is like 11 GB. Shit, that is big. And in LFS, when we do, if someone is doing LFS, they have to download not just this Linux kernel. They download this kernel, they compile this whole kernel, and on top of this, they get everything else. They have to download packages and all the amazing things which we can like actually see, read online in LFS, stable LFS, Eretra. What is that? Current stable. Okay, here. Look at this. Cross. These are some tools we need, and I think yeah, gzip, tarball to untarball, and these are all the packages we will be downloading and compiling. This is big. This is big. LFS. This is what you have to do if you are doing LFS. Building the LFS system, installing basic. These are basic system softwares, libgc, glibc, zlib. This is just amazing. This is amazing. This is very beautiful. This is, I guess, one of the best things a human being can do in their life. LFS. And yes, this is just, I'm just ranting. This is amazing. This is amazing. And with that, and with like saying that, yep, these are the things I will be doing along with competitive programming. So, and yes, I'm extending the limit for reaching the rating of 2000 by 1 year so that it is actually achievable. And yes, I'll be doing Rust projects in C, and from tomorrow on, I will be doing streams for the same, building our own Redis from scratch. And this is cool. Building database, we will be able to like learn about all of these things. Socket programming in C++, TCP server client, how they talk to each other, request response protocols, concurrency. We will be handling concurrency, handling concurrency, how mutex is used so that you avoid race conditions and everything. This is amazing. Event loop in the context of C++, that must mean something. Key value server. And then if you go to advanced topics, you will have balanced binary tree, maybe red black trees, or what are the other balanced binary trees? Red black tree is one of the balanced binary trees. We have sorted set, the normal set in C++, timeout, thread pool. That just sounds very beautiful. Thread pool. The need for multi-threading, that is just amazing. We will be building projects. Projects are just nice. Look at this. There mutex, mutex. We will be doing mutex, which is mutual exclusion. Exclusion here and mutual exclusion, mutex. And also for I will stream Rust only when I am building the project. So while I'm reading, I will not stream Rust. But when there are chapters where we are building projects like this one, in this chapter number 12, we will be building an IO, input output project, building a command line program. So I will stream this when I reach this point in the book. And the last chapter is amazing. Look at this. The last chapter, final project, building a multi-threaded web server. That sounds very cool. That sounds very cool. Not just the word web server, but if you put in this word multi-threaded anywhere, it just elevates what you are building. Multi-threaded web server, high from Rust. So this is what our web server will be returning at the end. So, and here we will learn a bit of TCP and HTTP. Networking is amazing. Networking is one of the most best, one of the amazing things human beings have been able to achieve after processors, of course. Processors are just beautiful piece of technology, and we will be learning about TCP, HTTP, and listen for TCP connection on a socket. And shit, this is just very cool. Socket. Our socket programming will become very strong because we will be doing socket programming in Rust and also in C++. Yeah, it will be amazing. Parse a small number of HTTP requests. So if we are going to use a library for parsing, then it is going to be a bit easy. But if we are making our own HTTP parser, then it is going to be very cool. And also we have create a proper HTTP response. I think we will not be using a library because they are saying we are going to create a HTTP response. That will be cool. Improve the throughput of our server with a thread pool. The word thread pool, we are seeing this for the second time. First we saw this here, I guess. Yep, thread pool. This is cool. This is very cool. HTTP networking stuff is just always very, very cool. I came late. Do you plan to stop CP for a while? Or no, I'm just saying I will not be going after it as very hard. So you're also making CLI. You can do HTTP in Rust, but not that good. Okay, we will see. Okay, it seems like you know a bit of Rust. That is amazing. And nope, I am not stopping C++. I'm just saying I am making it more achievable. I'm going to bed. I hope you have a good stream. Thank you. Shit. Okay, you were late. Shit. Okay, you were awake till 12 this evening, this afternoon. That is very admirable, I would say. So Rust is not preferred for servers. That is fine. Crates.io. Yes, the main thing is, okay, shit. I thought you were one of my friends, like literal IRL friends. His name is also UHH. Okay, that is lol, funny. Now, bro, I just saw learning. I watched Harkirat course yesterday. Shit, bro, just one-shotted Harkirat's 5-hour course. That is funny. How these things would make your goal in CP more achievable. Because I'm not burning myself out by just going after one thing. I have seen like in the past 1 to 2 years that if I'm only doing one thing, then I break down. But if I'm doing multiple things, then it is very okay because I have the option to switch between things when I get overwhelmed with competitive programming. I have Rust to fall back to, and I could also work on my project in C++ instead of just dreading. Yeah, so I can get refreshed when I get overwhelmed with competitive programming. I can refresh by learning Rust, and I can refresh by like this thing. And this is just the things I'm doing which are related to computer science. There are like novels also, and they are fine. Yeah. So if I'm doing multiple things, it is very good. So yeah, is so that since competitive programming reaching 2000 itself is a very tough is a easy word for it, because competitive programming is the hardest thing I have done in my life. I think anyone would be doing if they are into computer science. He gave two project ideas, CLI and some backend for your app. So I was able also thinking to do the CLI. Ah, yeah, CLI is nice. I would also like to make, there is a uh, type testing project in Rust, like type eraser in Rust, T-typer or something, CLI based. I guess this is the one. Yeah, cargo install T-typer. This project is written in Rust for typing, and shit. Let's run this cargo. Shit. This is still downloading. We have already downloaded. This is look at this. Git clone HTTPS Linux. We are cloning Linux kernel, and we have downloaded 2.2 GBs of this, and we are still only at 18%. That is messed up. Okay. Cargo install T-typer. Crates. Is you can find bug in that. There is some site where you have to debug the codes. That would be nice. I haven't read code written by other people other than competitive programming. In development, I haven't read code that is written by, not right now, but yeah, plans are there for LFSing. Yes, we will be doing LFS together. And look here, there was a person with the same name. That is like kind of crazy, or maybe this was your alt. This is pretty cool. Yes, I have a question. I have noticed that you are starting CP 4 months education and reached almost 14, 17 is the peak. Did you start from zero, or you were good at some stuff? That is, I would, well, I started specifically CP from zero, but I was doing other things. Like I did before CP, advent of code, which is very nice. Advent of code is like one of the best things. Yes, you can do this. There are questions on here, and this is just nice. But before CP, I hadn't read any algorithms material. So yeah, that was the first time reading about algorithms officially. Good job, learning. Yo, yep, LFS is good. He's me, his. Okay, bro is watching too much David Lynch, I guess. Python. Python is English. Yes, I would be able to read Python, but not write Python. My first language, Hindi. My first language was Python. No, it was C, by CS50. Yeah, CS50 was the first thing I did, and yeah, in CS50, wait, let's go there to the actual website. CS50 playlist, this one, and there they have first. Okay, shit, my first language was Scratch. Yeah, Scratch was my first language. Then came C, then Python, then HTML, CSS, JavaScript, and this was like so painful to just understand that HTML gives structure to the page, CSS gives style to the page, and JavaScript gives interactivity to the page. Just to understand this much, it was very, very difficult. Just to get this simple concept in my head. This was very difficult. And shit, they were streaming this. And these lectures are long, 3 hours long. Shit, that is crazy. That is actually crazy. They were streaming this. That is crazy. Yes, they were actually streaming this. Okay, there were no audience like normal CS50 lecture. Okay, yeah, that was it. School. Is- In school, I wrote Python, but I do not consider that as something because I didn't know what was happening. That was like very, very crazy. When you write input int name or something, yeah, I didn't understand anything that was happening. So whatever coding I did in school, it just ended in school. HTML structure, yes, CSS style, and JS logic, React development. Yep, yep. It was just too difficult to understand this for the first time. I don't know why. It was just very difficult for my brain to comprehend this simple statement at the start. So you started to code integral this year in general. No, I started coding in 2023, which was end of because I gave my JEE in 23. So yeah, after JEE, I started coding. Yeah, I studied Java in school. Shit, bro had trauma. Bro has some trauma from school. You can forget about it. But that was so basic, and I never wrote Java again. Yes, you should never write Java ever. Like, do not write Java right now. Don't write Java in the future, and don't write Java in the past. If you can stop yourself in the past from writing Java, stop yourself. And it's cargo T-typer. Yeah, how do we run this? T-typer. So T-typer is a terminal-based test build typing test built with Rust. It allows you to test your typing speed with a variety of tests, including random words, programming languages. Shit, that is crazy. Okay, and when I do install, how do we run this? Where does the thing go? Okay, there are a lot of dependencies. Compiling, 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 and where does everything go? It is right here. So if I cd into my tilde home directory and dot cargo slash bin slash typer, okay. Oh shit. Ah, okay, that was 95% accuracy. Okay, Q. Should I think I should add this folder to my like search folder so that if I type typer, it should just run. And we can do this by going to ZSH RC and here like just like this, and should I already have a one thing cargo, yeah, and source dot ZSH RC, and now if I type typer, it runs. That is nice. Java syntax is, yes, it is very bad. Did CP31 sheet worthy too? Yes, it is worthy. It is worthy. The only thing that I do not like, and I just came to know, is that these questions are old. Shit, see, look at this. I haven't done any questions. Shit. Uh, wait. Let me hide my screen. Yes, it is hidden. Just a second. Yeah, cool. Yeah, it is visible now. The bad thing is that these questions are old, like Gary Oldman. These questions are old, and the current questions at a rating of 1200, 1500, like on code courses, the current questions at 1200 or 1300 are as difficult as the 15 and 1600 rated questions here. So yeah, that just gave me false confidence. But yeah, that was the only bad thing. But yeah, it is overall a very good thing. You should do it. CB31. But I still remember such basic syntax as Java, like import and main function and buff reader. Shit, I don't know Java. I don't know Java. To read input, then using parse to change input into different data types. Yes, the same thing that we do in any, except in C++. In C++, when we are reading input, we are directly interpreting the input as the type that we are reading into using cin. Cin just amazing. Cin, that is just cool. The fact that we can just overload something is cool. And now to code forces, let's solve questions at 1300 rating, 1400. Yeah, 1400. Let's go. And yes, I will have to solve easier questions also, because yeah, just practice. Let's solve some random thing. I did this at some point. Any Photoshop, Photoshop, photo shoot for gorillas. Okay, this is the question that we are going to do. And yes, we will be doing some questions in this stream. That is nice. You should try solving them. Just solve till 1200, then recent contest problems. That is a nice idea. Yeah, I mean, solving how many problems you solved? Yo, divine tree yesterday. It is this one. See, let's see. And yes, since I now do not have a strict schedule or like today's the day I do this topic, that kind of mentality, I'm more free and I can just do whatever I like in the moment. So that is also nice. Let's start the stopwatch. Tmux skill server, Tmux attach, TCP, yes, Tmux set, attach, TCP. Okay, cool. Start win. And this is the question. Okay, this is by some Indian person. Wait, 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 wait. Okay. Harshit attained enlightenment, shit, in competitive programming by training under a divine tree. Divine tree is a rooted tree, a tree connected tree. Okay, rooted tree. Okay, with n nodes labeled from 1 to n. The divineness of shit. I feel like I've seen this question before. Uh, the divineness of a node V is denoted by a dv function is defined as the smallest node label on the unique simple path from the root to the current node. The smallest labeled node. Okay, that is the divineness of some node V. Okay, the smallest simple path. There is only a unique simple path. Yes. Aryan, being a hungry competitive programmer, asked Harshit to pass on the knowledge. Harshit agreed on the condition that Aryan would be given two positive numbers n and m, and he has to construct a divine tree with n nodes such that the total divineness of the tree is m. Okay, if no such tree exists, Aryan must report that it is impossible. Okay, desperate for knowledge, Aryan turned to you for help in a complex task. Okay, so what do we have to output? If possible, if not possible, then -1. Otherwise, divine tree. Okay, here we have 6 and what? At least we have to add, right? 4 and 6 was the thing. So we are getting numbers 1, 2, 3, 4, and we have to add at least 4 numbers. So can we choose 4 numbers among these such that the sum is 6? And we can just choose 1. 4, we can choose 1 2 times. So we have different possibilities. 1 plus 1 plus 2 plus 2, that is 6. And we also have the possibility of choosing 1 plus 1 plus 1 plus 3. And we can make 1 as the root. If we like get some arrangement where we can add 4 numbers to get this, then let's make a tree for this. So 1, and then we want 1 to be added for 1, and it will be, and for the node number 2, this is the thing, and you want to add 1 for the node number 3 also. And then for node number 4 we want to add 3. Then we cannot do this. We cannot add 3 unless we make 3 the root. Okay, so we have to make the biggest number in here the root. We make 3 the root, So 3 will be added when we are looking for the path from 3 to 3, it will only have one node and 3 will be added. And then for every other node, we just want to add 1. So we can just attach them. Yes, we can just attach them to 1. And this is a working tree. What do we have here? We have 3 connections, 3 edges. Yo, we have 3 edges here. Okay, and we are saying 3 is the root, I guess. No. 1, 2, 3, 4. 1, 2, 3, 4. And the first thing for each, the root of the tree. Okay, so 3 is the root. 3 is the root. Uh-huh. 3 is the root, and it is connected to 1 directly. And then yeah, this is literally the same tree which we made here. 2 is connected to 1, and then 4 is connected to 2, or to 1 directly, does not matter. Yeah, this is nice. This is nice. So we just have to find out, first of all, a configuration which has to have if we have n nodes and m is the sum, then we need to find a way, and then we will get numbers from 1, 2, 3, 4, dot, 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 till end. Yes, and our goal would be to add n numbers together among these numbers from 1 to n, so that their sum is m. So the minimum value we could have is n when all the numbers are equal to 1, and the maximum value, what would be the actual maximum value? Yes, the maximum value would be n into n plus 1 by 2, because when we are finding the divinity of a single node, then that divinity is either going to be equal to this node or is smaller than this node. So the maximum a node can have is going to be its own value. So yeah, so the maximum would be 1 plus 2 plus 3 dot 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 till n, which is just this. So if m is within this range, then okay, and if not, then not okay. And if we like, if we want this to be the divinity, we can make 1 the root and connect everything in just series like this. Like, now no matter how we are connecting anything, we will always get 1 for their divinity. And if we want to achieve the maximum sum, then we can make n the root, and then we can connect everything in the descending order. Then we will make a connection of n minus 1 to this, and then n minus 2, just like that. Yeah, we will keep going. So I think, and also every other configuration between these two sums should be possible. I think it should be possible. And if it is, then we got here minus 1 because m was too big. Okay, so now our task comes down. We can divide this whole question into 2 parts now. First is finding out what n numbers do we choose to make up m. And I think if m is possible, then this is like now coin change, and we can always, since the amount of precision is too much, we can go with We cannot go with the greedy algorithm. We can go with the greedy algorithm actually. When n equals 4, we have choices 1, 2, 3, 4. And what we will do is 6 is our total sum. We will see how many 4s can we take. How many, the maximum number we can take, how many times. Unless, and the condition is going to be, if we do take this maximum number once, then let's say m is our total answer minus some x amount of n. N is our current maximum number. This thing is going to be the remainder which remains, and since we must use n number of numbers to get up to a sum of m, then this thing, this is our first choice, x, uh, then the number of numbers which are remaining would be n minus x. Yes, so this thing should be greater than equal to this thing. Why? Because let's say here we want a sum of 6 and we are asking how many 4s can we take. When we take 1 4, then we will get x minus 4, and the remaining sum would be equal to 2. And we cannot achieve this using 3 numbers. The total number of numbers that we must take is 4. We have to use exactly 4 numbers to get up to 6. And if we use just a single 4, the number that remains is 2, which is a bit too small to be reached by 3 numbers. So we cannot take 4. We will go to the next biggest number, which is 3, and we will see if we use a single 3, the number we are left with is 3, and we have to get up to 3 using just 3 coins, which is okay, cool. Okay, this is cool. This is cool. Yep, this is cool. So you can always use greedy if you have all the numbers from 1 to n. Yep. The only thing that I am like not liking is how do we make sure that we are only using n coins. Like we have to exactly use n coins. Coins is not the right word, but yeah, we have to use exactly n numbers. And since yeah, we have the choice to use anything we want. We can use a bunch of ones, and yep, we can use a bunch of ones, and then no, we won't use a bunch of ones to begin with. We will see how many times we can take a big number. Wait, should we cannot take a big number more than once? We either can take it or not take it. Yeah, shit, yes. If we are, because whenever like we went to 3 only because we were unable to use a 4. So if we were to use 3 more than once, if we were to add 3, this is 6, which is like already bigger than 4, and we were unable to use 4. So we will only use this current number once. Okay. Okay, so now we will be just asking, we can just run one loop from top to bottom, like from n to 1, and see which numbers we are going to use. And when we do have that vector, which tells us which numbers we are going to use, it will have a bunch of ones and some other numbers. Then we need to find the edges, and that would be easy to do, I think, if we have this thing in descending order, in descending or ascending order, sorted order. Okay, let's do this. First of all, we have to check if it is like at least even possible, and shit, m can be quite big. Okay, okay, we have n and m. long long mx maximum sum is going to be n into n plus 1 divided by 2, and minimum is just n. So if m greater than equal to n and m smaller than equal to mx, if that is the case, or if that is not the case, if m smaller than n or m greater than maximum, then cout -1 with a new line and return. Otherwise, we got this. Otherwise, we got this, and let's create a vector response e response, and for int I equals n minus 1, I equals n, I greater than 0, I minus minus, and okay, int rem equals n. We have to use n numbers, and n are remaining. And if we use the current number, which is I, so if m minus I, we do use the current number, this is how much is left, how many numbers are left. And if this is greater than or equal to rem minus 1, then it is okay to go with this number. Then it is okay to go with this number, and we can do m minus 1 equals I, subtract I from m, and also rest dot push back, not rest, let's call this nums, the numbers that we are adding. Rest doesn't look good. We will use rest for our like final answer, for storing the final edges if we have to store them. Then push back I, we are going to use I as a thing. Else, wait, let's handle here when greater, and if exactly equal m minus I, if after using this current number, we are left with just ones, a bunch of ones, equal rem minus 1 and shit. So, okay, rem minus 1 minus, we have used one number. So we updated m, we updated nums, we updated rem. That is nice. And in here, we'll do the same. Wait, actually, we don't have to do this. After this, we will just check if m minus, if m equals rem, if the current sum that is remaining is equal to the current number remaining. No, maybe we have to use all the numbers from, we do we don't have to use all the numbers. We can skip, we don't have to use all the numbers. We have to use n numbers, but which of which we have the choice from using, for using all the numbers from 1 to n, and we must choose n numbers from this range. But which numbers we are choosing, that is up to us. We can choose anything we want. So if rem equals this, then while m, or while rem dot push back 1 and rem minus. Cool. Okay, that is nice. And let's see if the program is working till now. Yo, that is messed up. Uh, Input 2 1, and 2, it gave 0 and 2. Okay, something messed up is going on here. We are taking in t, we are taking this thing, minus, we do not see -1. And yes, we do not see -1. See out n space m. Okay, we are getting 1 and 2. That is good. Should not rem. Shit, my bad, my bad. But nums. Okay, in that is wrong. This is wrong. Shit. Okay, something is wrong. Greater than equal to shit. Okay, okay. So what is wrong with this part? N would be equal to 1. 1 into 1 plus 1, 2. So 2 into 1 divided by 2. 1 into 2 divided by 2 should be 2. Should be 1. Right? And okay. Now we are getting -1 for here and the, okay, shit, yes. My bad. After this we break. Cool. So this is the array, or this is the choice. This is like the 4 choices we are going to make. And this is nice. This is nice. And I think what we have to do is, since we want this number, we cannot, we have to make this number the root. So yes, the first number is going to be the root. We will add it once, and then in the order that we see numbers, we are going to make the pairs. So now what you have to figure out is, given the choice of numbers which we are going to add, we have to make a tree which adheres to this choice. And this thing is in sorted order from highest to lowest. And this number is, we need to add this number. So we cannot make this, this is the biggest number that we are going to add. So we cannot make the simple path which we are going to use to reach to a number have a number which is smaller than this. So which simply means that we have to make this the root. So we will have to make 3 the root. And now we are left with 1, 2, and 4. And the next number that we need is 1. Right, we need 1. So the next, okay, this is going to be one pair. Yes, makes sense. The first and the second, this is going to be one pair. I think we can just put them in this. No, we cannot just put them in this order. Now the second number that we need is similar to the last number. Yes, this is similar to the last number, so we have to use a number that is bigger than 1 to get this. And yeah, which is bigger than 1, and we have 2 and 4 remaining. We already have used 1. Okay, we will say our final answer is going to be of this form. I think there is a name for this thing when our tree is a single line. Yes, our tree is going to look like this. And when we see a big number like first number, we will have a couple of things: last and I, which is the current root. And I will begin with 1. 1 is the second element, and we will not start from 0. We will start from the second element from our choices, and we will also keep track of the last one. Here, last one is 3. And we will compare the current one with the last one. And if, wait, we don't have to keep track of the last one. Yeah, we don't have to keep track of the last one. We will just compare I with I minus 1. I is 1 and I minus 1 is 3. These are different. So we have to make a connection between 3 and 1, which we say by this 3 and 1 are connected. Then our I moves on to this thing and we compare I with the last one. They are same. Now we have to use a number that is bigger than this number. That is bigger than this number. And yeah, what are the possible choices? Shit. What are the possible choices? We can use the possible choices since every other number that is not 1. Let's write some other configuration for reaching this. Yes, we can use 2, 2, 2, 2, 1, 1. This is also 6. Right, let's go with this. So we are making 2 as the root. Makes sense. And our I goes here. And we compare the last one with the current one. And we have to use a number that is bigger than this current number. Yes. Well, this is a position which should never occur in our method which we are using, because we will never use any number which is not 1 more than once. In our array, we will only get any number that is not 1 just once, and we can use that fact. We can actually use it. We can use that fact. We can use it to our advantage. Yes, let's use it to our advantage. And yeah, okay, cool. Cool, 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 cool. How do we know which numbers have been used and which numbers have not been used? We will use our Boolean vector. Yeah, everything is like true. Used is, it is going to have n plus 1 things. Yes, and everything is by default going to be true. And then we will start traversing through our numbers vector. So for int I equals 0, I less than n. I will start from 1, I less than n, I not, yes, n, it has n numbers. And we will first of all see what the root is, which is res, nope, which is nums 0. That is the root. And after that, yes, if ai equals ai minus 1. Nope, they will not be equal. If ai equals 1, then we do something crazy. Yes, if ai equals 1, then we will make a link between the last number, then cout ai minus 1 space 1 space 1 and new line, and break. But even before we break, we will say we used the number ai minus 1. Wait, shit. Let's make everything false by default. Nice, nice. Else, if the current number is not ai, then we will say, cout ai minus 1 ai new line. And we just used AI minus 1 equals A used AI equals true. And when we exit, use AI minus 1, we have to see if there are any numbers which have not been used, then we will have to use them. For int I equals 0, I equals 1, I less than equals to n, I plus plus, and if not used I, then cout attach that number to I. AI attach that number to 1. Space 1, new line. This makes sense. Yes, AI, like what is AI? Except we also have to say use 1 equals true. Mhm. We are here using the word AI equals 1, which is wrong. We have to use nums. Shit, why are we using A all over? Substitute A with nums. Use AI here. Substitute A with nums. Nums, not nums. Okay, that is nice. And 3, 1 are connected, and 2 and 4 are connected to 1. Cool. Cool. Is this going to work? Here we are getting n and m. Here we are getting n and m. And here we are getting the maximum value. And if m is either smaller than n, which is the minimum value we can have, or m is greater than the maximum value, then no, this is not possible, and we return. Otherwise, we do get to see what the answer could be. We have to use n number of numbers at least, and this is going to be our way. Yeah, this is going to be our method, and this just seems uh, pretty cool. Here we are seeing we can use every number from n to 1, and we are checking how many numbers are we using. Mm, okay. If the current number, if after using I, the remainder that we get is, yeah, if it is achievable by using a bunch of ones, then we do use the current number and we push it back into I and do this and that. And if at any point the remaining m is reachable by using the remaining number of coins as 1, we'll do this. We will say while remainder, we will push back 1 for all the remaining numbers. Yeah, cool. And I guess there must be a better way to do this, to extend a vector by some known amount. Yep, there must be a better way to do this. Anyways, and then vector bool used n plus 1. Yeah, we are saying which numbers have we used. We have used. And nums 0, it is going to be the root. What if 1 is the only thing that we are using? Then still we would say that 1 is the root. Okay. Then we say we are beginning from n equals to 1. Okay, this is bad. Yes, no, this is amazing. This is okay. Yeah. If the current number is 1, then we make a connection between that last number and 1 and we break. Otherwise, if the current number is not 1, then we make a connection between that last number and the current number and we move on to the next number. Okay, cool. This should work. Let's see, 33 minutes. That is good enough. Let's see. I guess this might work. Hmm. Or maybe not. Everything here seems good. What are the limitations of n? 1 m is 10 power 12. Is that a problem? No, that should not be a problem. M is long long. Rem is not long long, maybe. So that should not be a problem. Yep, that should not be a problem. What if m equals to 0 and rem equals to 0? Okay, so if m and they are also equal. Yeah. Well, if that was the error, then we should have gotten time limit exceeded, not the current error that we got. If this was the error, anyways. While rem, shit, even if it was the error, then no, this is fine, this is fine, this is fine. If m will never be negative. Yep, m will not be negative. Okay, then vector bool used size n plus 1, cout is 0, that is our root. Okay, if we are using ones completely, then we'll just attach everything to 1. And this is also okay. Here we are making one edge. Yeah, we might be making an edge with 1. Yeah, sure. Okay, so we have to handle the first case. Uh, if nums 0 is not equal to 1, only then do this. Otherwise, yes, do this. Yeah, only then do this. Else, if everything is just a 1, then connect everything to 1. So for int I equals 2, I less than equal to n I plus plus, cout, connect I with 1. So now if we say the name is g plus plus e divine 3 dot slash out, we have just one test case, and let's say we are using 4 nodes and 4 of them are 1, then yes, 1 is the root and everything is connected to 1. Okay, cool, shit. Okay, this should be amazing. This should work now. And this should also work for all the other cases. Should. Okay, yes. Okay, it is at least passing test number 2. Okay. Seems to be working. Okay, how many test cases are there? And how did you do this? Like, if you are still here. And shit, I guess earlier these IDs didn't used to come. It was your actual YouTube name, but now instead of the name, IDs are coming. That is an update. Accepted. Nice. Again, that was cool. That was cool. And yes, before moving on, we'll have to go to the washroom. I'll be right back in a minute. And yep, I am back. I used two vectors, one for storing the numbers is used, before one is used, should I, that makes sense. We don't have to store all the numbers till one, okay, yes, shit, that is very stupid. What I did, one is used, then rest in the second vector, then just printed cache all the numbers before one, and this makes sense. So we can skip this step. It's like, it's not this, we can skip this step. This does not make sense. We can just break. Yep. And this should still work if nums 0 is not equal to 1. Then do this, yeah. Uh, for I1, I smaller, yes, if the current one is 1. If we ever get to 1, we will break. Yeah, we don't have to use multiple ones here. Yeah. Yeah. Okay, maybe we did have to use multiple ones there. Should yes, we have to add at least one there. Rest dot or pushback one. Yeah, cool. This should also work. This is nice. This is nice. Yeah. Storing all the numbers before using one. This just makes a lot of sense. Wait, we don't even have to do this. We don't even have to push back the one here. We can just break. Aha, shit, this makes too much sense. This makes too much sense. We can just break, remove this else. Okay, and see out is telling what the root is and not going till n, but res dot, not res nums dot size. And so like if we know we have to use n nodes, n will be the divine of all, n will be the divine of all nodes below it. So I did rem equals m minus n, then find out what is the number we have to use to make up the rem. And you can check my code. Okay, what do you mean by rem equals m minus n? because so like uh, if we know we have to use n nodes, n will be the divine of all nodes. So you are making sure that you are using n. Let's see. Profile, Aditya Singh, 82. Yo, submissions, divine tree. Let's go first. Try. Shit, you are using a lot of memory. Wait, am I also using a lot of memory? No, shit. Wait, I guess you messed up somewhere. NM, if n greater than m or this thing, yes, see out. Okay, that is cool. Then m minus n vector long a and v. If and you are going from top to bottom. Then if m is greater than equal to I, we do use I and push back into this. Else if not, then push back I. B dot push back I. Okay. A dot insert A dot B back. Okay, insert at the end of A everything from the beginning of this thing. If m is not equal to 0, then see out -1. M would be equal to 0. Is this working for like the first test case which has been given to us? Uh, should I can write a new file from right here. Uh, uh, hello.cpp. Get copy, and okay. Hello dot c g plus plus hello.cpp out slash out. Run the thing and pass in the first test case. I feel like this should break on the second test case. I mean, this is a wrong, correct submission, but I just feel like this should break. Like once we use 1, then all below 1 will have divinity 1 on. So it got accepted. Yes, it got accepted, but I don't know why. It feels like it when we have 4 nodes and 6. 3, 1, 1, 4, 4, 2. 3, 1, 4, 2. 3142 would be our final A vector. Yes, it did get accepted. Yes, that is, yeah. Uh, because, okay, shit, yes, makes sense. Okay, shit, I messed up. My bad. M cannot be, wait, you would be able to use, so 6, M is equal to 6, N is equal to 4, M becomes equal to 2. So then the next thing that you can use, I, it would be equal to 2. So 4 and 3 go into this vector B. Okay, 4 and 3 go here into B, and then you use 2, and then 1 goes into B. So in A, we have just 2, and in B, we have 4, then 3, then 1. So final A becomes 2, 4, 3, 1, and I guess this is what the final thing becomes. Where did your submission go? Here. Uh, A dot insert. Okay, this thing, like, eh, okay, then see out 0 plus 1. See, at the start we do have 2, so you output 3. Okay, how is this working? How is this working? Why do we have to add 1 here? And when we do add 1, we are going further till n minus 1, and we are, okay, our loop 0 indexed. Okay, so we are checking 3 2 1 0, 3 2 1 0. Okay, then still 2 would be the one which goes there, and this whole thing would look something like 3 1 0, 3 1 0. Yes, 2 3 1 0. This is the final thing, and we are saying 3 is the root, and then there is a connection between 2 and 3. Shit, plus 1 plus 1. No, no. M, after we do this, m is equal to 2. So when I is equal to 2, we do this, and m becomes equal to 0. So 0 also goes into A. So we have 2 0 3 1 in this order. Okay, then we are saying 3 is the root, and there is a connection between 3 and 1 to make this one indexed. We are saying there is a connection between 3 and 1, then there is a connection between 1 and 4, then there is a connection between 4 and 2. Shit, I do not understand why this is working. This is working. This is working. This is literally working. And minus 1 is 3. So yes, 2 and 0. A has 2 and 0, and B has 3 and 1. Yep, that is crazy. This is crazy. I don't get this. How this is working. This is step, because you are saying there is, so like we know, if we have to use n nodes, n will be the divine of all nodes below it. So I did rem equals m minus n. N is going to be the divine of all nodes below it. N is going to be the divine of all nodes below it. I think this thing is working because here your I is 0 indexed, and since this is 0 indexed and you are going to use like n things, and all of those n nodes are 0 indexed instead of being 1 indexed starting from 1, they are starting from 0. So, and in total we have n nodes. You have removed 1 from all of them n nodes, therefore doing this beforehand makes sense. I think that is why this is working, like technically speaking. Okay, this was a nice question. This was a nice question. Yep, let's see some other question. Maybe skibidi. There was something skibidi table. And before moving on, let's the tutorial. See, nice. Yo, we got nice people here. Bro is online right now. He might be watching our stream. Shit. Uh, 623 problems, and bro is pretty cool. Look at this, look at this. In just 600 problems. That is nice. That is nice. But not just that, he has been at this for a while. Bro has been here for a while. He was kind of struggling, I guess you could say, here before people, and then he pushed himself forward, and he went to 1500. That is amazing. And then a little down, and then he pushed again. That is nice. That is nice. His peak is right there. Yeah, that is nice. Yo, yeah, that is why I guess we need time. Time is a good factor. And this guy, what is this? Shit, maybe he is the one who wrote the like announcement and something messed up happened and people did gave him a few downvotes, I guess. Shit. Unfortunately, today we found out that one of the harder problems was an exact match to an earlier published problem. Therefore, we have decided to only hold the Division 2 round. We hope for your understanding. It will now be 6 to 7 problems and you will be given 2 hours to solve them. Shit, they messed up a little bit 4 months ago, and bro's contribution is like shit, top negative. Shit, top 10 negative. 180 problems is crazy. 180 problems is crazy. 180 problems is crazy. I told you we already did minus n, so now remainder 2 remains 2. So which the is for the test case. I do get it why like how it is working. It just shows online randomly even when you are not online. When you search him in dialog box, you get real info. When I search him in dialog box, where this one right here. Aryan Sangeet. Okay, here last visited 16 hours ago. Okay, this is the actual thing, but this was not the guy. Our guy was this guy. 04 and 1 minute ago, and last visit 1 minute ago, but he is somehow online now. Code first forces the what is happening here? Okay, he wrote the editorial for the same round. Okay, shit. He wrote the editorial for the same round. He also got negative voting. But did bro survive the negative rating? He did. He did survive. Shit. But his friend. No. But his friend died. Shit. Shit. This is too much. Okay. Getting to the solution. Hint. Yeah. Currently it is showing correct. But many times it happens. Yep. Yeah. I think I've also seen that happen sometimes. And on to the solution. What are bounds on M and N to geometry? Yes, we know. The lower bound is N and the upper bound is N into N plus 1 by 2. And do you know how the story about Mr. Gauss, how he came up with this formula, supposedly, allegedly, when he was a child, like 6 years old? What he did was, since our task is to do this, and I think people know this, dot 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 till n, we can do let's say this is s, and we can say add these 1 plus 2 plus 3 No, should write this in opposite order. N plus n minus 1 plus n minus 2 plus dot 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 plus 2 plus 1, and here n minus 1, this is minus 1 plus, and we can write this sum as 2s equals 1 plus n is n plus 1, and here 2 plus n minus 1 is also n plus 1, and everything is just n plus 1. The last one is also n plus 1, n plus 1. And since we have n numbers, we are going to have n amount of n plus 1s. So this comes out 2s equals n into n plus 1, and divide by 2. We get s equals n into n plus 1 by 2. That is pretty cool. And Gauss, like Gauss from maths, he was able to do this when he was 6 years old. So that is pretty cool. Yep, this is the solution, and yeah, I guess we have it. We did this, so that is fine. Now, skibidi table. Reset. Okay. Hence proved. Yes, hence proved. Let's go. Skibidi table. Vadim, Russian. Vadim loves filling square tables with integers, but today he came up with a way to do it for fun. Let's take, for example, a table of size 2 by 3 square table with rows numbered from top to bottom and columns numbered from left to right. Okay, so top left line, like right here. Then we place 1 in the top left cell, 2 in the bottom right cell, 3 in the bottom left cell, 4 in the top right cell. That is all he needs for fun. Unfortunately, Vadim, he has a table of size 2 power n into 2 power n. He plans to fill it with integers from 1 to 2 into 2 power n, which is the size of the total table in the whole area. 2 power n into 2 power n, 2 into 2 power n, 2 in 2 power 2n. In ascending order, to fill such a table, Vadim will divide it into 4 squares, 4 equally square tables, filling the top left and top left one first, then bottom right, followed by bottom left, then followed by top right, followed by bottom left, and finally the top right one. Each smaller table will be divided into even smaller tables. Okay, 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 and it is always divisible because the side is a power of 2. So we will, at the end, we will hit a table of size 4, and yeah. So what do we have to do? 8, 9, 10. Wait, shouldn't 9, 10 be here? Okay, third thing is the bottom left, and fourth is the top right. Okay. Finally, top right, each small table fills them until he reaches size 2 by 2, which he fills in this manner. Now, Vadim is eager to start filling the table, but he has few questions of two types. What number will be in the cell XY, and in which cell coordinates will the number D be located? Okay. Okay. Shit, that is a good question. That is a good question. And n is 30. Can we like literally make the table? And the number of queries is 2000. And what is the memory we can use? 256 bytes. I think we can just make a map. But 2 power 30 is too much. 2 power 30 is too much. 2 power 10 is 1000. 2 power 30 is 1 billion. We cannot have that much things. Yes, cannot have. So we have to make some like, yes, we cannot simulate and find everything beforehand. Okay, so we have to write some formula. Wait, this is this. So we can like literally find out where the thing goes whenever we are like asking a query. Instead of storing everything beforehand, since we do not have a lot of queries, we can figure out, we can simulate every time we are asked something. But no, that is also not possible because n is 2 power 30 and n is 2 power 30, which is like 10 power 9, and this is the maximum side a square can have. Therefore, the total number of cells is going to be 10 power 8, and that is not good. 10 power 8, and that is not good. Okay, let's do something about it. We have a big thing which we are dividing. Okay, so let's have a reference here. If we have a small thing, then first we fill this, then second, then third, and then fourth. Okay, so here I think we can simulate. If we have been given a number, we will see which at a step. Okay, at the first step, r squares has the size 2 power n. This is the side of the squares that we are dealing with. Right. And this is like binary search, but in 2 dimensions. Binary search. So we have to see when we have been given a number d, and the total numbers are from range 1 to 2 power 2n, right? And in this range we will have a left and a right value. Left would initially be equal to 1 and right would initially be equal to 2 power 2n. These are everything that we have, and we will see d, where this d lies, and it would depend. So okay, how are these things going to be distributed in 4 things? And okay, this is going to be distributed in 4 things, in 4 equal parts. The range from left to right, where left and right are included, this range is going to be divided into 4 equal parts, and the size of those equal parts is going to be r minus l plus 1, since l and r both are included, and divided by 4. This is going to be, let's say, delta size of each of these singular distributions, and then we will see in which one does our number d lies, and according to that we will change our left and right thing. But we also need to output the coordinates. Okay, so we will also have a track. We will have like 2 coordinates. What are the coordinates of these points? Here we have some number in this square, and here we have a number in this square, and here we have the smallest number is here. Yes, the smallest number is always here, and the biggest number goes to the top right. the biggest number goes to the top right. And let's also, while we are moving, we will shade. Yes, we can take X L and X R and Y R and Y L. Y L is saying the answer either has this Y coordinate or higher than this, and YR tells us that the answer is on this YR coordinate or before this, and YL does the same thing to the right of this thing or on this thing, and XR also does the same thing to the left or exactly here. And whenever we are like changing our original L and R pointers, we will also update these two things, and whenever we exit, we know we have hit one of the numbers, and whatever when we exit, XL and XR would be equal to each other, and YL and YR would be equal to each other, and that would be our answer. Dot. Okay, that seems good enough. That seems good enough. Seems good enough, yes. Python boilerplate, and also let's here key say 1 4 3 2. This is how we like go into the things. First we go to the top left, then bottom right, then bottom left, then top right. And how is the input given? This is n, not n, this is n, this is n, and the size of this, the initial side would be 2 power n. Yeah. And q. And what we will do is we will write a function, two functions actually. One function will give us a long integer which tells us 911, which tells us which number is at this current coordinate. So num tell us which number is in the location long. Yes, let's use long x and long y, and this is all we have. Shit, if we do know the location, that is nice. If we do not know the location, we will keep shrinking the left and right positions, these two things, and at the end they will be pointing to, they will be equal to each other, and that would be our answer. But before this query, let's write answer for the other query, where we are returning a pair of long long wait, these things don't have to be long, they can suffice as an integer. But yeah, this, yes, this pair can also be an integer returned, and find, that is not a good name, where, let's say where, and this takes in a long number, long, let's say n, and tell us where n is. Okay, and also we need, this thing needs the size, so let's call this x and int n, the size of our square. Long L equals 1, and long right will be equal to 2 power n plus 1. 2 power 2n. 2 power 2n minus 1. 2 power 2n. No, shit. Right. Did we have 16? We had 16. So, and 2 was equal to n was equal to 2. So 2 power 4, 16. Okay. R is 1 long left shifted by 2 into n. That is our right limit and int x l x r y l y r x l equals y l. Both of them are equal to 0 initially, and x r equals y r y r, and both of them are equal to the right limit, which is 1 left shifted by n. 1 left shifted by n minus 1. Minus 1. I think that is nice. 1 left shifted by n minus 1. Okay, now we will do our narrowing down thing while, and we know that the correct number is in the range L to R, where L and R both are included. Right? L itself could also be the answer. R itself could also be the answer. So we will do this while R is greater than L, because if at any point L becomes equal to R, we would like to exit because we already are at the number. Okay, now diff size, let's call this size. The size of each segment is going to be R minus L divided by 4. R minus L divided by 4, R minus L plus 1, that is the size of our whole range, and divided by 4. I hope I'm correct. I hope I'm correct. Okay. With this, now for int I equals 0, I less than 4, I plus plus, because like there are 4 different possibilities. Now, if we are in the first segment, if we are in the second segment is over there, third segment. Yes, shit. First segment is here. I think we can store this thing in a map so that this is easily achievable. We don't have to build this into the code. Okay, let's first get this done, then we can like make this pretty and all. Okay, so if this, yeah, I guess. So if we are checking if the number is in the first top left segment, if it is, how do we check it? We will see if x is greater than equal to L and x is smaller than equal to L plus size. If that is the case, right, we make the R limit equals L plus size. And not just that, we now, shit, can we now shrink the XR limit by 2? I think no, we cannot just half it. What we can do is, I guess, int initial C diff as in like difference in coordinates. Initially, it would be equal to XR minus XL. And since X and Y coordinates are not changing with the same ratio, so yeah, it is going to be different for all of them. And if in the first X changes and Y also changes. Yeah, YR will change and XR will change. Okay, yes, sure. It is same. And coordinate diff initially was equal to XR minus XL. Now this whole thing right shifted by 1. Okay. If we are on the top left corner, then we have to shift XR minus equals C diff and YR minus equal C diff. Is this correct? If this was initially, let's say, 0 to 4, 0 to 3, 0 to 3, if this was like initially 0 to 3, then we would do 3 minus 2, and yeah, this is fine. This is fine. Okay. Else if, let's check if X is in the second range. In the second range, which would be X greater than equal to L plus, wait, equal to, we have to take care of equal to. 1, 2, 3, 4. So here we do not do equal to. Yep. Here we do not do equal to. Ah, shit. Okay. Here we do not do equal to. No, we do equal to. But we don't do is smaller than. Yeah. Yeah. Here we do not do equal to, but here we do equal to this thing. And X is smaller than equal to like the bigger range. L plus size plus size. If X is here in the bottom right, which is like here in the bottom right, then L will change, R will not change. How will L and R change? Is L and R will become equal to these new things. L becomes equal to L plus size. Yes, and R becomes equal to L plus size minus 1. And now we have to change XR and yeah. How XL will increase? XL plus equals C diff and Y R remains same. XL changes, yes. YR, YL also changes. YL changes. YL plus equals C diff. And at the end, we will like always do right shift this number by 1 just in case. Yeah, cool. Okay. Shit, there are other conditions also. If this number is in the third place, which would be, yeah, X greater than equal to L plus SZ plus SZ and X is smaller than, we cannot use equal to here, smaller than L plus SZ. This looks bad. 3 into SZ. If that is the case, then L equals L plus 2 into fz, and r equals L plus fz minus 1. And which coordinates are we going to change? YL will increase, XR will decrease. YL plus equals C diff, and XR minus equals C diff. If that is not the case, then L equals L plus 3 into fz, and R equals L plus fz minus 1. We would be in the top right, in which case XL minus equals C diff, and YR L increases. Yeah. YR minus equals C diff. Okay, shit. Okay, and then we would just output the coordinates of this number, which are return XL and YL. Okay, it means this much should be correct. This one part of the program should be correct. So while q minus minus, we will take in how are they saying, how are they giving us the query? Okay, this way. String s c in s. If s equals this thing, then we are asking for which number is at this current coordinate, and yeah, let's say x comma y, c in x, and y and c out high. We have not implemented this part yet. Else, if that is not the case, then int or long d, taken d, and what does our function return? Where is the name of our function? Then auto x comma y equals where d n, and see out x space y with a new line. Eh, Okay, wrong answer is good, but error is bad. Okay, it is not zero indexed. Uh, Okay, why do we always say 1 1? 1 1 is not the thing, is it? Nope, 1 1 is not correct. Yes, there is also some edge case. D is okay, D is correct, and X and Y are also correct. 2 power n. N is equal to 1, and we are asking for the number 8. How can we ask for 8? There are 8 queries, not that we are asking for 8. There are 8 queries. We are saying 1 1 is here, And we are also saying that 2 is at the same place, which is not right. Which is not right. Something is wrong. This is 1, 15. Let's say, okay, we are looking for 15 in this thing. And our left limit is 1 and our right limit is 16, initially speaking. Yeah, initially our left limit is 1 and the right limit is 16, and the difference would be 16 minus 1 plus 1, 16 divided by 4, which is just 4. And okay, so in the first query here, 4. In this part, L is equal to 1 and L is equal to 1, and we are asking x, which is 15. 15 is greater than equal to L, which is correct, but less than L plus size being 4. 4 plus 1 would be 5. And yes, that is not true. And it would only be true when we are here, which is the fourth case. This one is x. No, which is the fourth case here. Size is 4. Size is 4. 4 into 3, 12. 12 plus original value of L is 1. So 13. 13 and 13 plus 4, 17 minus 1, 16. R is 16. L is 13. Which is correct. 16 to 13, all the numbers are here in this range. And laptop is going to die. Okay, then we go on. And did the okay, so we are messing up when the size of the square is just 4, right? When the size of the square is 4. If sz equals 4. Let's see. If sz equals 4. So if, yeah, if x equals L, then we are in the top left corner, in which case we do xr minus minus, and okay, let's change L and Y first. L will remain as it is, R will become equal to L, and we will say xr minus minus, move the right limit to the left, and yr minus minus. And break or does not even matter. Else if x equals L plus 1, R equals L, L plus plus, R equals L, and in this case x L plus plus and y L plus plus. Else if x equals L plus 2, which is bottom left, in this case L plus equals 2, and R equals L, R equals L, and Y L plus plus, and X R minus minus, else L L plus equals 3, and R equals L, and we are in the top right corner, X L plus plus, move the left side of the x coordinate by 1 to the right, and xl yl, in the y we do yr minus minus. Okay, no, Still not on the mark. Nope, nope, nope. We're here always seeing this thing. This is not good. When size equals not 4 but 1. Shit. Okay, yes. At least 2 are correct. Okay, and we messed up here. Why did we mess up here? It's L space XR space YL space YR and then underline, and we will only run this for the okay, there is something wrong. There is not anything, nothing wrong. Line 12. Okay, yes, this makes sense. We have just one test case, and yes, one test case. It has like what's it, just one query. N is equal to 1, and it has one query, and that query is asking where is the number 3. Shit, I messed up. I messed up. We have just one test case where n is equal to 1, and we have only one query, and that query is where is the number 3. Should I messed up? I messed up. I messed up. We have just one test case where n is equal to 1, and we have one query. I think this is how we do this. Where is the number? Uh, where is the number 3? It is at the location 1, 2, which is correct. Actually, x1 and y2, which is correct. When are we asking for 3? The third thing is what? Here. But they're saying it is at 2, 1. Which cells are the coordinates of this and this? Okay. Yeah, I guess we messed up in reading how the thing is. What number will be at this location? What are the coordinates, and how are the coordinates coordinated? Like here they are saying that 15 is 15. This is the output. 15 is at the place 2, 3. 2, 3. 2, 3. Okay, row, column. Okay. Okay, we have to change the things here. Shit. 2 and 3. So first they are telling the y coordinate, and then the x coordinate. We can just like switch the order here. Yeah. Except this thing. Shit. 2, 3. Everything else is matching except this. Okay, now that is matching and not this. When size equals 1, it would be when R equals 16 and L equals 30. We will do 3 plus 4, yes. So minus 1, okay. Size would be equal to 1. And in this case, okay, L is 13, then, no, L is, we would go in this case, actually. I think we are changing this thing in the wrong way. Let's see, let's see. X equals L plus 2. L is 13, 13 plus 2, 15, 15. X is equal to 15. Cool. So L becomes 15. R also becomes 15. And we are changing the left. Should we have to change everything, I guess? We are changing the left value. YL. Wait. Yes, yes, that is correct. That is correct. And then YR minus minus. Okay, so something is wrong. Initially, this value is equal to 1, and this value is equal to 4. Since n is equal to 2, so this value is equal to 4. Okay, and hello, 154. Okay, this question is fun. This question is nice. X is greater than equal to X. X is greater than, okay, let's update everything to match this coordinate system. This would be if X is, okay, this is the first coordinate, and in the first coordinate, X is representing the row, and if we are in the first coordinate, then we will just, yeah, move both of these back. And if in the second one, then we increase both of them. Yes. But if we are in the third one, then we will increase X, XL. We will increase XL. Yeah. So this has to be X, and Y R will decrease. That makes it Y. Yep. Nice. And this will become Y, this will become X. Is this correct? If we are in the fourth coordinate, XL, no, YL will increase. Yes, YL is increasing. And XR will decrease. Yes, XR is decreasing. That is also nice. Okay, so what do we do here if the current one is the correct one? When they are like both changing in the same way, then it is okay. Here, X becomes Y, Y becomes X. XL, XL, and YL. YL. Okay, last one is correct. Why is this thing messing up? Why is this thing C out XL space Y XR space YL space a normal space and YR and then a new line. Delete this from there and put this there. And size was equal to 1. Compile We have just one test case where n equals 2, and we have just one query, and that query is where can we find the number 15? Okay, we can find the number 15 at locations 2, 2. And how did these two things change? XL didn't increase. Only YL increased. Y shouldn't even increase. No, Y should increase. Y should increase. But XR, this thing should have become 2. And the actual answer for 15 would be 2, 3. Yeah, this thing should have become 2. We are doing this. So why didn't XR change? One test case, n equals 2, one query, tell us where can we find 15. It did change, but the change is wrong. Half, 4, change should be by 2. Change should have been by 2. 4 to 2, 1 to 2, and this should be from 3 to 4. Shit, yes, okay. So, div x minus L plus 1. Shit, yes, yes, yes. I messed up here. Or we can also write this thing as 1 left shifted by n minus 1. Okay. Now, okay, yes, we got at least half of this correct. Now we have to work on the other half where we have been given a number and we have to tell where this current number is. Wait, that is what we did. When we have been given coordinate system, we have to tell where do these, where does, what number is there at that location, which it will get in, no, this should be called, no, no, where is I? Which number is this int x and y when int n is the thing here. Okay, we will have to initialize all of these things, the same thing. Again, 5, okay, okay, that is nice, that is nice. Now instead of comparing the other things, we will be comparing the coordinates. Yes, we will be comparing the coordinates. Yes, we will be comparing the coordinates while r greater than L. Now, current coordinates. Okay. Okay. Number is between L and R and current coordinates. Let's first check X. If X is greater, if the X coordinate of the target is greater then XL plus C diff greater than or equal to, then it means the answer is in the bottom half, Okay, and now we have to check for the y coordinate. If y is greater than equal to y L plus C diff, and if this is true, then the thing is in the like bottom right. Yes, bottom right. Ah, yep, bottom right. And we will have to change these numbers accordingly. Okay, so XL becomes plus equals C diff and YL plus equals C diff, current diff. Okay, that is nice and shit. I don't think we have to do like what we did there. Return return one. I think we don't have to do this much. Or this if sz equals one. This part seems stupid. Comment this, run, and yeah, it is still working. Yeah, we don't have to use this part. Nice. Okay. And how do we change the left and the right limit? We are in the bottom right, which is the second one. So L size is going to be equal to R minus L plus 1 divided by 4. So when we are in the second thing, L plus equals SZ. Yes, and R equals L plus SZ minus 1. Else, this would mean we are in the bottom half, but on the left side of the bottom half. Yep, left side of the bottom half, and we will change XL plus equals the div and YR minus equals C div. And bottom left is the third case, so L plus equals C 2 into SZ and R equals L plus SZ minus 1. Else, if we are in the top half, we will ask the same questions. Okay, here what do we have if we are, okay, so we are at the top half and on the right of the top half. If we are on the right of the top half, XL will increase, XR will decrease, my bad. XR decreases and YL increases, that is right. And this is the third thing, so yeah. 3 into Z, shit. 3 into Z and R is also correct. And XR minus, and this would be, we are in the like, yeah, so just reduce these two. L is not changing. L is not going to change in this case. L will stay put. Return L. This would be which number is at xy and see out with the solution response with the answer and okay, we messed up only in this case. Okay, why did we mess up here? 2, 3. We were looking for 2, 3. In this thing, 2, 3. Wait, in this thing, 2, 3, 2, 2, 3 is 15. In the first one, we miss. Wait, huh? In the first one, we are looking for 4, 3, 4, 3, 4, 3. My bad. We are looking for 4, 3, 4, 3, which is 7. Okay. But we said 5. So we messed up somewhere. Yeah, that is very cool. We messed up somewhere when we said 5. Why did we say 5? 5, 5, 5, 5 does not make sense. 5, 5, 5, why did we use 5? There, xl equals xy equals 1, and that is amazing. That is pretty cool. Okay, that is even correct. Shit, we are not changing cdiff. Right shifted equals y1. Key. Now, finally, this might be correct. Let's see. Let's see. Let us see which is a book. Okay, 123 lines long. If this is correct, there should not be time complexity error. Yeah, TLE error. TLE error. Yeah. Okay, cool. This does work. That is nice. Okay, so this only took time, like in doing. This took 55 minutes because of the implementation. And this was nice. This was a nice question. This was a nice question. Yep, good. That is nice. Like, cool. Yes. I guess that would be it for today. It has been 2 hours and 27 minutes. That would actually be it, I guess, for today. And from tomorrow, we will be doing amazing things, which is we will be building a project in C++. Boom, a project in C++. That is just, that sounds very good. We will be building our own database in C++. This thing, build your own Redis. Let's add this to the bookmark bar. DB database. Yo, let's go. Yep, this is going to be the thing, and this is cool. Yeah, this is what we will be doing, and tomorrow, not today, tomorrow we will be doing this, and that for today would be the end of the stream. Yep, we only streamed for 2 hours and 28 minutes for today, and that is fine. That is fine. And thank you for being here. This is the end of today's stream, and thank you for being here. Bye.